All right, let's get started with the last 1 hour of the 1.5 hours of the session. Since this final evaluation will be in the TensorFlow, will be in the image classification. I'm discussing one more example in the image classification. So, similar concepts which we discussed last year and last week I'll be discussing with regards to TensorFlow TPU. So it will be some kind of a revision for you. So TensorFlow, melanoma, whatever object detection we had planned to discuss today, we have completed that. So this is one more example for TensorFlow, TPU, TF records, and image classification problem. Because like as a Kaggle competition, we'll have one Kaggle competition kind of format where data set will be given to you, and in that 3 hours you will be submitting a pipeline, preparing a notebook, and then you will make a submission, and you will submit your notebook also. It is not just making a submission, you will submit your notebook as well, which will be evaluated for each and every student. So it is going to be an image classification problem. So I'm going to discuss one more problem today, so which is melanoma classification. So skin cancer is a very important, very deadly type of cancer where a lot of people are melanoma as a type of skin cancer. And so yeah, so the whole problem statement is to detect people melanoma from lesion images. So this is the whole problem statement. So we are going to see the data set. So this problem is brought to you by Society for Imaging Informatics and Medicine and International Skin Imaging Collaboration ISIC and Society for Imaging Informatics and Medicine. So these are two collaborative societies which are bringing together this competition. So melanoma is a deadly disease. So we are seeing some real world healthcare problems. So you can take a similar kind of data set and make your final project as well. These are very, very research problems. So this is all coming from research labs, the data set and everything. These are very relevant for the society. See, one thing you have to notice is this is being hosted from North America. They are organizations where, in some of the hospitals in North America, these are things which are tried out, but in India, it is still many doctors are not implementing such things. So you still have scope for, going to the Indian doctors, catching up with the doctors, finding out what their problem is. How many of you ever thought of collaborating with doctors and all that, solving their problems using AI? Has somebody really tried that? Like collaborating with any social worker, solving some real world problems. One of my batchmate is a dentist, and after getting to know that I'm a data scientist, he pinged me, and he was giving a lot of use cases in dentist as well, and he was saying he wanted to collaborate a lot. But the fact is, again, doctors are busy and I'm also busy, so we couldn't collaborate on it. But there are a lot of doctors who have ideas, very creative ideas, but then they don't have a time to sit and do AI and all. You can reach out to a lot of people, because India is a country where we don't have sufficient mental healthcare resources for everyone. The doctors are not willing to travel to remote villages or remote places to go and treat there. In Tamil Nadu, there's a mandatory time that you have to go and work in villages and rural places, and that if that condition is not there, nobody will go to rural places. So there are a lot of people in several parts of India who don't get proper access to treatment. AI cannot replace human doctors, but places where people don't have access to access and money and the resources to go to a human doctors, at least AI can be at least help them get diagnosed quickly. And a lot of things goes undiagnosed and gets diagnosed in the advanced stage, which is what is creating a lot of problems. So AI can help a lot there. And so this is one such problem coming from a couple of research labs, which is Society for Imaging Informatics in Medicines and International Skill Imaging Collaboration. These are two research organizations which are coming together, and they're organizing this competition. And International Skin Imaging Collaboration is an organization which has huge public repository of imaging data sets. So you can go to the ISIC websites and check out the several public repository of data sets, which you can use it as a research problem, get started as well. So this is the ISIC category website. See, you have high quality image data sets. So you can check out several image data sets. Melanoma type, melanoma ulceration, several images are there. So you can actually download several archive of images are there which you can download, and you can start, publishing research papers using these research data sets. So the evaluation metric here, this is a classification problem in area under the curve. You have to mention the image ID and the probability that it has a Lessian images. That is what you have to give. So we also have so the data is, you have a train CSV file, which is a training set, test CSV file, which is a test set, and sample submission CSV file, which is a sample submission file. And you also have several columns here where you have image name, which is a unique identifier for image. You have a patient. For every patient you have a unique identifier. For you also have gender, you have the age of the patients, and you also have whether it's a malignant or benign or less yet. You also have a target variable and the diagnosis information. So these are additional data which has been given to you in the metadata as well. So let's get to the coding. So you have train CSV file, test CSV file, sample submission CSV file. The best thing is the data set they have already converted into TF records and they have given it to you. This is a very good thing. You have a training data set, test data set, and you also have images in the form of JPEG. So if you want to use JPEG, you can go and use it. If my code is going to be in TensorFlow, so for me, TensorFlow records is very good. It sits well with TPU. It sits well with lot of TensorFlow libraries. So TF record is an ideal choice. But the problem can be solved using JPEG also. So the notebook which is going to be discussed now, I'll share it in the chat window. Please check your chat. I've shared the notebook in the chat window. Kindly check. So we have already seen the objective of this competition. What is SIAM? What is the organization name? What is ISIC, this organization, and what is skin cancer? Why is it very important to study about skin cancer? We've seen skin cancer is the most prevalent type of cancer. Melanoma is responsible for 75% of skin cancer's death. See, melanoma occurs very rarely, but if it occurs, then it is mostly in the fatal side, and there's a higher probability of person dying. So it's very important to get it diagnosed as early as you can, so to avoid fatalities. So the statistics is available only for US. It is diagnosed. There were over 100,000 new melanoma cases diagnosed in 2020 alone, and it is expected that 7,000 people might die from the disease in 2020. So this is why melanoma is a type of skin cancer, and it's a very fatal type of skin cancer. It occurs rarely, but if it occurs, there is higher probability of death, and that's why it's important to diagnose it early. And deep learning for computer vision can play a huge role in diagnosing melanoma from lesion images. So this is the problem statement. So it is a binary classification problem. So you have to classify if it has got melanoma or the images doesn't have melanoma with certain amount of probability. Okay. So you're installing all the libraries which is required. EfficientNet is a pre-trained model which I'm also installing using pip install. Then other libraries also I'm installing. So for accessing Kaggle data sets from GCS Google Cloud Storage, I'm importing the Kaggle data sets thing. After installing the EfficientNet, I'm importing the EfficientNet as well, and all the tools which is required, TensorFlow and stuff, I'm going to import. So we have already learned about tensor processing unit. See, tensor processing unit and GPU, can anybody tell me which is faster, TPU or GPU?
TPU is faster.
TP is faster.
Good. TPUs are very, very fast, especially for deep learning, and especially any operation which involves a lot of multiplications. And you should TPU may not be the ideal thing for a tabular data, but for anything which involves extensive multiplications and all these deep learning based operations, TPU is a great choice. That is why people are see a lot of people are not having GPUs, and they're struggling to buy costly GPUs. TPUs, if you learn it, Colab gives V38 TPUs, which is much much faster than GPU. At the same time, you get it in free of cost itself. So that is why you should become a proficient in TPU, so that you don't have to depend on, you don't have to sit and buy your GPU and all that. So the TPU which comes in Colab, what is the version of TPU which comes in Colab? Anybody in the class who knows that? What are the two versions? What are the two models which are available? So there are multiple TPU cores available. See, one which is available in Kaggle and in Colab, it gives you a V38 version. It is available, and it gives you 16 GB of HIVM TPU core. And so this is what is about TPU. And most of the Google powered apps is already running in TPU. So internally they started out to build some efficient accelerator. That's how TPU got started. At some point they wanted to make it available for public as well. TPUs are still a proprietary of Google, which means you can access TPU only using Google Cloud and the Google ecosystem like Kaggle, Colab. Outside that, you may not be able to access TPUs. When it comes for performance, ResNet 50 performance, TPUs, you can compare the performance with GPUs and TPUs. TPUs are outperforming GPUs in this case. You can see the diagram explains the performance strategies. So you can have TPU initialization. So the TPU process, last week itself I taught you there's a bunch of code which you need to put whenever you want to initialize TPUs, which is you need to create the cluster resolver object, and then you should connect to the cluster and then initialize the TPU. So these are four things. Then create an object of TF distribute experimental TPU strategy. So these are four steps. Whenever you create TPUs, you will have to do all these four steps. So there is something called auto tune. Why do we use this auto tune? TF data dot experimental dot auto tune. The reason why we use auto tune is there are a lot of hyperparameters and parameters in the model, which will be which you don't have to give any values right now. Automatically, the best values will be chosen at the deployment time or the run time. So that's why we give auto tune, because sometimes you might give certain values which may not work well in the runtime. So automatically, the best values for hyperparameters and parameters will be picked at runtime if you give auto tune. So we are actually using TPU and all. So TPU, you have to create a Google Cloud Storage thing for Kaggle data sets. All data sets are already there in Google Cloud Storage. You can get it using .get GCS file. So the batch size, it's recommended. Morning also we had discussion about batch size. What is the recommended batch size? See, batch sizes you can start from 16, 32, 64. You can keep experimenting and find out which works for you. And the image size in this competition is 1024 into 1024. So this is about various parameters. So I'll stop here and wait for questions. If there are any questions up to this point in understanding the data set or TPU, how to initialize TPU, and you have any questions up to this point, you can let me know, and then we'll proceed to the TF records. So next up, if nobody has doubts so far, next up we have TF records. So TF records is a TensorFlow zone binary storage format. You can convert anything, Word document, lines of text, or JSON, encoded image data, or serialized in the TF tensors, anything into TF records. So TF records is actually a sequence of records. And so this any you can convert anything. So here we are converting images into TF records. And so now if I have to read these TF records, I'm going to read the train TF records, and then I'm going to divide it into validation and training data. So I'm going to split the training data into validation and train data. So I've been discussing about TF data. Can anybody tell me what is TF data? We learned it last week also, sometime back also I discussed it. What is TF data? Why do we use TF data? So if you see this diagram, it is more than self-explanatory. So if you use input data pipeline, you can enable parallel processing and saves you a lot of time. And if you don't enable parallel processing, it's sequential input output processing, it takes you a lot of time. So this is the advantage of using TF data. So TF data is used for building complex input pipelines. Okay.
TF data and TF records are both the same.
No, TF data is different and TF records is different. TF records is a binary storage format. TF data is an API for building input pipelines.
Thanks, ma'am.
Yeah. So how many people have doubts here? We'll proceed to till here. Anybody has doubts, you can ask. So yes, TF data API, what we will do is here we have some representation called TF data.dataset. It's just an abstraction which TF data.api uses. So TF records, you will convert it into TF.dataset format. The reason why you do that is once you do convert it into TF.data.datasets, there are a lot of functions which you can use, which will make your jobs easier. And it's very easy to build an input data pipeline. So there are a lot of utility functions. This is how the utility functions calls itself each other. And so these are utility functions where, if you want to decode an image, then you have a function for it. For reading a TF record, for loading the data set and all that, you have different utility functions. The next is data augmentation. When you say data augmentation, you can either do it using tf.image or using you have Keras pre-processing layers to do the augmentations as well. So tf.image, I've just used a one random flip left right, but there are a lot of augmentations which you can use using tf.image. And then you can get the training data set, validation data set, and test data set. And this is the learning rate. Here we are using a cyclic learning rate. So this is the efficient net. So a little refresher. Can somebody tell me? We discussed the efficient net research paper briefly last time. Can somebody remember the summary point or main point of efficient net architecture? So all of you were sleeping in the last class. What is the main concept behind efficient net? We discussed efficient net so many times in last week.
Based on deep learning, and we can also use transfer learning to uh, retrain the model.
Mhm. Increase the depth of the model, but the efficient net increases height, depth, and resolution, all three by a constant coefficient. So this is known to have shown a tremendous performance gains compared to the predecessors. So the efficient net increases the height, width, and resolution by a constant coefficient. This is about the efficient net architecture. And the performance of AsiaNet is equally good. It is performing really better compared to the other predecessor architectures. Now you have to understand one thing: strategy dot scope. Strategy.scope is what from here only the TPU exit. Whenever you mention strategy.scope in your TensorFlow code, only after that point the TPU execution will start. So you are getting the training data set, test data set. Then you're calling this pre-trained model efficient net, and you're just uh, chopping off this classification part and then adding few more layers and training the model. You're setting the optimizer as Adam, loss as binary cross entropy, metrics, and then you're training the model. And once the model is trained, you're fitting the model and making an evaluation. So this is about the efficient net. This is what is the melanoma classification. We have solved using efficient net, TensorFlow, TF records, TF.data API. I'll give you 10 minutes time. I want you all to go through this example. And if you have any doubts, you can let me know. We will also be going through one more example. It's 4:12. I'll give you like time till 4:30 to go through this example. And if you have any doubts, you can ask, because we're going to go through one more final example. I think last week itself we covered around three use cases. So this is the fourth use case for image classification. We'll be covering one more use case for image classification, real world use cases. So these are real world use cases. It's not some toy examples, MNIST and all that. These are like real world, somebody is using these models. So go through this code if you don't understand anything in TPU, tfdata.api, how to do fine tuning of the model, how to do transfer learning and all that. If you have any doubts in this notebook, you can let me know. There's one more use case I'm going to cover at 4:30. With that, we would have covered 5 use cases. So you should be in a good position to crack your final assessment. Yeah, catch you at 4:30. Just go through this notebook. If you don't understand, you can ask doubts.